And lastly is yung the area 5 ng network plus domain 5, which is the given a scenario troubleshoot general networking issue. So last area na siya ng domain 5, which is the network troubleshooting domain. And I will um I will be commenting the video again of Professor Messer entitled General Network Troubleshooting N10008 CompTIA Network Plus 5.5.
Whenever we run into some type of network problem, this might be affecting one or many devices on our network. We want to try to resolve this problem as quickly as possible. Before we start modifying any type of configuration, it's best to understand exactly what we're working with. So you may want to log into your switch, your router, or whatever device is having a problem and look at the configuration of that device. You may do this through a web-based console, or there might be a command line that you use via SSH. If this is a device that's involved in a change control or you're performing some type of upgrade or modification, it might be useful to gather this information prior to the event. That way you know exactly what you're working with when you sit down to make those changes.
So, yung SSH or terminal console na sinasabi niya dito when configuring a device, yung SSH, pwede mo siyang gamitin if you wanted to configure the device remotely. And kapag terminal console naman is, pwede mo siyang gamitin kapag yung physical device or sa mismong device ka magko-configure. You can use the PATI for SSH, and also you can use command prompt for Windows and terminal for Linux.
I've just logged into the web-based front end of one of the switches on my network. There is also a command line with SSH that I could use to view the configuration and make changes. I thought it would be easy to see all of this in the web-based front end. You can see the system summary tells me exactly how this device has been configured. It's in a layer 3 mode because this switch acts as both a switch and a router. I can also look at firmware version. So this device is using firmware version 1.3.7.18. It also has a separate firmware version because I did upgrade this device from 1.3.0.62. This makes it easy to revert back to a previous version if I run into a problem. So I can upgrade to the latest version, and then if this happens to have some other type of bug that I wasn't expecting, I can easily revert back to the previous config. If you're working with layer 3 devices, then you're dealing a lot with routing tables. Routing tables are a way that your device knows where it should be sending traffic. As traffic is inbound to this layer 3 device, the destination IP address will be examined and compared against the routing table. That routing table will then either forward that traffic to the next hop or drop that traffic because there was no entry for that destination in the routing table. If you have a lot of routers on your network, you may want to build a map so you know exactly where a packet should go whenever it needs to get to a destination network. Sometimes these routes are created automatically through the use of dynamic routing protocols, or you may be manually configuring those routes in every device. If you have a lot of routers on your network, you might want to create a map that shows exactly where the paths are for each individual subnet. This way you'll be able to map out where traffic should go, and you can confirm that based on the routing tables in each of those routers. This is a key troubleshooting step if you're running into a routing problem. You not only need to track every router as the traffic is outbound, you also need to make sure that your routing tables are correct for the inbound traffic as well.
So, yung routing tables na sinasabi niya dito is the table wherein pinapakita niya yung traffic ng information. Ay kung saang device, kung anong IP address siya pumunta or nanggaling yung information. Sa Linux, you can use the tracer root command. Input mo lang siya sa terminal. And for Windows, you can use the tracer command.
If you're configuring static routes in a device, it's very easy to accidentally create a loop. You might tell router A to send all traffic to router B, and then you might accidentally tell router B to send all traffic to router A, and then that traffic simply loops around until the time to live is expired and those packets are dropped from the network. You also want to be sure you're not missing any routes, so make sure that you not only map the outbound routes, but also all of the inbound routes. Let's look again at this switch that I'm running in my studio, which also acts in layer 3 as a router. I see 3 individual static routes in this device. We have a network 10.1.10.0 and a network 10.1.20.0 that are locally connected to this device, so no route is needed. But I did add a static route for everything else. This is the default route of 0.0.0.0, which means anything that doesn't match all of the other destinations in this routing table would be routed to the next hop, which is 10.1.10.1. Let's say that I'm at my desk and I need to communicate to a network that's located at 10.10.10.1. You can see that 10.10.10.0 is not listed in this network list, which means it's going to follow the default route of 0.0.0.0. That means I'll need to look at the routing table that's at 10.1.10.1 to see what the next hop might be.
So, just to inform you na kung ano bang ibig sabihin na static IP. So, kapag sinabing static IP, yun yung IP address na na-set ng user. Kung yung sinet mo, kung ang gusto mong IP address is 192.168.0.1, yun yung static IP address. Hindi na siya mababago kung kahit connect siya sa ibang router na may ibang network. But, meron din tayong tinatawag na DHCP. Yun naman yung automatically nagbibigay ng IP address sa device. Kung ano yung network ng router, yun din yung network ng computer.
Here is the Comcast Business Gateway that acts as my 10.1.10.1 network. And you can see there is a list in its static routing table of 10.10.10.0, which is my house network. And you can see that the gateway IP or next hop address for that network is 10.1.10.211. Now I would go to that next hop along the way to determine where the proper routes would be from that device. You would follow this path through all of the routers on your network to confirm that all of your static routes are configured properly. If you're having problems with a single device communicating on the network, then it might be useful to understand how that single interface is configured on your switch or on your router. So you may need to refer to all of the different settings for that individual interface on that device. The first obvious step is to check for connectivity. Is there a link light? Is traffic passing through the device? And if it is, you can then look at the individual configuration settings for that device and make sure there's not a duplex mismatch or an issue with the speed settings. Here's a list of some of the devices that are plugged into this interface. I can select any of these interfaces. This one happens to be up and enabled. But if I move to the edit option, I can see all of the different configuration settings for SNMP, auto negotiation, auto advertisement, flow control, and other settings. This allows me to confirm that what I've configured on the switch matches the configuration setting that I've configured on the device. If you've connected a device to a switch and you find that its DHCP address is not in the subnet that you expected, or it simply can't communicate to any other devices on the network, then it may have an incorrect VLAN configuration. Every interface on the switch is configured as an access interface, which would be for an individual device, or it's a trunk interface that's designed to transport many VLANs across a single link. So the first step would be to look at the configuration of your switch, identify the interface where you're plugged in, and then identify what VLAN is configured on that interface. If I connected to interface 4, I would be on VLAN 100. If I connected on interface 3, I would be on VLAN 254. You can see how easy it might be to plug into the wrong interface and suddenly be assigned to the wrong VLAN. So this would be an easy check to make sure that you've either plugged into the correct interface or that you've configured the correct VLAN on the interface for that device.
So, yun nga. Sabi niya is kapag hindi same ng VLAN yung ating devices, hindi sila magkakakitaan. So, kung VLAN 100 yung laptop 1 and VLAN 200 yung laptop 2, hindi sila magkakakitaan. Pag sinabi nating magkakakitaan is that walang connection in between them. Para magkaroon ng connection, kailangan nasa same VLAN lang sila. For example, yung laptop 1 and laptop 2 is nasa VLAN 100.
Information. It may be taking a long period of time, so it might be useful to see a series of trends or a baseline interface, or that you've configured the correct VLAN on the interface for that device. Sometimes problems can occur over a long period of time, so it might be useful to see a series of trends or a baseline of information to see if you can recognize where problems might be occurring. This may allow you to see what the overall utilization of the network might be at certain times of the day, or you may be able to drill down into a specific device so you can see exactly what that user may be doing. Your organization may already be collecting this information. It may be taking logs and consolidating all of those logs in a SIM, or you may have NetFlow or some other type of collection mechanism to be able to see statistics over a long period of time. From here, you can look at certain times of the day, you can identify what protocols may be traversing the network, and you can look for any errors or problems associated with those conversations.
So, common software na pwedeng mag-check ng ganun is yung Zabbix, Cacti, and Observium. Meron dun, mache-check mo yung CPU usage or kung may error dun sa system mo. So, that ends our video. And it also ends the discussion about the areas of the main 5 of the Network Plus certification.